Okay, so in this video we continue with our tutorial. We're going to start with question number 12 and then hopefully we can continue to question 13. Okay, an AC circuit consists of capacitors 1000 microfarad connected in series with 50 Hz source and a lamp of 2.5 volt 0.3 ampere. So here I already draw the diagram. So took out all the information. So notice that this one is the rate for the lamp. So it's 2.5 volt and 0.3 ampere. So I put it over here. In AC alternating current circuit, normally we represent the lamp with the resistor itself, because the filament is basically the resistor. And this one is actually your VR. Okay, so some students they didn't realize this thing lah. If this one is for the lamp, that one is actually voltage across the resistor. Okay, so for the first question, calculate the reactance of the capacitor and the resistance of the lamp. So basically the question want to find XC and R. So if I want to find XC, I can use the formula of 1 over 2 pi FC, since the F and C is given, so 50 and 1000 microfarad. So now it's basically just substituting the value 1000 microfarad. Oops. Okay, and then make sure you write in the correct unit, because XC is basically just a resistance, so it will be in ohm. Okay, question number, okay, same question, but the next one they want to find R. So they already give you the V resistor and I across the circuit, because basically this is just a series, circuit in series, so all the currents is the same. So this is basically I RMS and I across R. So I just gonna write it over here. So for series, circuit in series, I can write that IR equals to I RMS, which is in this case just 0.3 ampere. So if I were to solve V equals to I want to use this one as R. This one should be IR. Okay, so this one should be VR, but because IR is basically same with IRMS, so R here will be 2.5 divided by 0.3, 8.33. Okay, so I think it's best if I write VR over here. Okay, and then they want to find the impedance of the circuit. So you already have R and XC. This is XC circuit. So like I told you before, if you have the main formula of Z equals to square root of R squared plus XL minus XC squared. So basically just close whatever the component that is not inside the circuit. In this case XI is not the circuit, so that one close your hand, include negative as well, so you have R squared plus XC. But obviously if you draw the phasor diagram, you can see that this is the formula. Z equals to 8.33 squared plus 3.18 square. Okay, don't forget to take the square root. So Z that I got here is actually equals to 8.92. Okay. Question number 3, they want to find the voltage of the source. So voltage of the source is basically VRMS. So if I want to find VRMS, I can use Ohm's law, but remember if I put V, I, the partner here would be Z. Do not put R. So common mistake, student will write this one as R. So IRMS is basically just IR, which is equal to 0.3. Z is the impedance, which is equal to 8.92. Okay, don't forget that this one is in ohms as well. So this one you will get 2.68. Question number 4, voltage of the capacitor. So now they want to find VC. So if I want to find VC, I have to use IRMS ataupun IC, but here IC is basically IRMS. This one, the partner will be XC. Okay, so notice that if I were to write this one, it would be V equals to IR. Okay, so it's basically just IRMS lah. And this one is IZ for VRMS, partner dia Z. For VR, partner dia R. For VC, partner dia is XC. So it will be 0.3. Oops. Okay, the XC is actually equals to 3.18. Ayo. So now you should get, how much you get? This one is 0.95. The last question, actually they ask you, question number B, explain why the total between the voltage across the capacitor and the lamp is not the same as the source voltage in A3. I think the question state that why when VR is added with VC, you didn't get VRMS. So if I were to draw those things, maybe I can draw it like this. So in DC circuit, I'm going to write this one. This is VRMS equals to 2.68. Okay, let's see, this is the VR, which is equals to 2.5. Yes, 2.5. And this one is VC, which is 0.95. So basically the question asks you why when we add up 2.5 with 0.95, we get 3.45. So that one is not the same with the VRMS here. This is the difference between direct current and alternating current. So you can see that this one, the main reason is because the current inside alternating current, it does not move together in the same phase. Okay, so if you draw the phasor diagram, you will see that the current inside the capacitor will lag behind the VR. So the VRMS is somewhere between there. So maybe I can draw the phasor diagram over here. Okay. This is your RMS. This is your VR. This is your VC. This is your VRMS. So if you want to find the VRMS, you have to take the vector. You have to consider this as a vector lah, like Pythagoras. Okay. Okay, for question number 13, an AC source of 10 volt and frequency of 50 Hz is connected. Okay, so this one is state AC source of 10 volt. So that one is actually your VRMS. Okay, so if the question didn't state that one is voltage across any specific component, resistor ke, capacitor ke, inductor ke, that means that one is for the VRMS, which consists of inductor of inductance 2 Henry. So that one is your inductance value. Resistor of 1 kilo ohm. So I already draw the circuit. So whenever you get the question, please draw the circuit so that you can get the idea what is the type of the circuit. and normally it makes things much easier. Equation number A1, determine the current flows in the circuit. So obviously you would like to use VRMS equals to IRMS. So most of the time, the step of solving alternating current equation, you might have to start from here. Okay, and normally student will make a mistake. They will like typical Ohm's law, V equals to IR. Okay, ini yang buat everything goes wrong. So instead, you should write VRMS, IRMS, Z. Why do you need to use Z? Because you have a circuit that has more than one component. Okay, so I told you before and so many times, whenever you have a circuit more than one component, if I want to write VRMS, IRMS, the partner will be Z. Okay, if I want to write if I want to write this one as R, this one need to be VR. Okay, so back to this question, you want to use this formula. Okay, but you need to find the value of Z first. VRMS is given 10 volt. Okay, so if I want to find the current, I need to find my Z first. To find Z, obviously you can use the formula Z equals to square root of R square plus XL square. But I need to find my XL first, so I'm going to find the values of XL using the formula of 2 pi FL. Okay, so for XC it's 1 over 2 pi FC, but this one is L. So the frequency is given 50, the inductance is 2. So I got here is 6 to 8.32 ohm. Okay, and then if I want to find my Z, I can use square root of R square plus XL square. Again, you can go back to the equation that I used before, and then you can tutup with your hand whichever component that is not in the formula or in the circuit, sorry. So this one will be 1000 square plus 6 to 8.32 square. So it really depends on your decimal points, how many points that you take. The answer might differ slightly. Okay, so in this case I just use 1181 ohm. I think this one will be 0.1 ohm, but I just leave it like this. Okay, maybe I think I have to use 2 decimal place. 0.1 ohm. Now back to the initial question where they want to find the current flow. So IRMS equals to VRMS divided by Z. So this one is basically VRMS divided by Z. So it will be 10 volt. Oops. 10 volt divided by 1181.01. So here I got 8.47 times 10 negative 3. Okay, that one is for the first question. Question number 2, they want to find the voltage across the resistor and inductor. So just now what you calculate is VRMS over here. So now the question want to find V inductance, sorry, V across the inductor, VL and VR. So you will expect if I want to use VL, if I want to calculate VL, I need to use IRMS XL. Okay, if I want to find VR, I have to use IRMS R. Okay, so I repeat again. So if I want to use VRMS, I need to partner this one with Z. If I want to use VL, I have to partner with XL. If I want to use VR, I have to partner with R. So that's the main idea lah. So IRMS is 8.47. So basically just substitute the values. XL is 6 to 8.32. So please press your calculator according to the things that you write. Okay, jangan tekan lain, tulis lain. So here I got VL as 5.32. Okay, and the unit will be volt. Don't forget the unit. And for some reason, I think alternating current is one of the common student problems that they forgot to write the unit. This one will be multiplied by 1000, which turns out to be 8.43 volt. Okay, so I just gonna bring this one a little bit to the left. Okay, so that one is for question A2. A3, they want to find the phase angle between the applied EMF and the current. So applied EMF is basically VRMS lah. So in this kind of situation, it's best if you draw the phasor diagram. You have VL, you have VR, VL, VR, and VRMS over here. And then you also have current over there. So this is basically your IRMS. This is your VR, VRMS, and VL. Since the question is to find the phase angle between the supply voltage, so that one is your VRMS, and the current for the circuit, which is IRMS, so the angle will be here. Okay, so this is your phi that you want to find. So if I want to find cos phi, obviously I can use if I'm referring to this phasor diagram, I can write this one as adjacent over hypotenuse, which is VR divided by VRMS. Okay, but you know, sometimes student might forget to draw the diagrams, so maybe they remember something like cos phi is equals to R over Z. Can I use this formula? Yes, you can use this formula as well. So just solve this one. So your phi is equals to cos R divided by Z, which is equals to 1000 divided by 118.01. Okay, obviously you use a different, a little bit slightly different decimal place and values, so the answers might differ slightly. And then if your calculator is in degree, then your final answer will be in degree as well. Here I got here's 32.14 degree. Okay, so if the question were to find power factor, so you just use R divided by X. But the question now want you to find the phase angle, phi. So you have to cos this one. Okay, don't get mixed up. Question number B, actually the question asks you what happened. Where's the question? Okay, explain why the total between the voltage across the capacitor. Oh, that one is different question. It suggests a way to make the voltage to be in phase with the current in the circuit. So you can see that here VRMS is not in phase with IRMS. Got a phase different here. So the omega will be in that direction. So got a phase difference between VRMS and IRMS. So what is the method I can use to make sure that VRMS is in the same phase with IRMS. Okay, so obviously VRMS is over here because of the VL. So because there's an inductor, there's a voltage inside the inductor, the VRMS change slightly over there, or differ slightly over there. So to solve that one, you can remove the inductor, from the circuit. Obviously, if you remove that one, then you will have a circuit with just a resistor. So basically, you just have VRMS over here. Okay.